Hey everyone, I just wanted to make this short video about this week's experiment, which is measurements. All right, so there's a quick objective, purpose, background, and material section to read, and then the procedure is actually only this long. So it's pretty straightforward. After the procedure, there are 4 report pages. The actual experiment part will be reported on the first 2 pages. And after that, then it's just some extra questions to answer on the next pages. So you should be able to work through it in a normal lab period time, and I'll sort of give you some information about how it's going to go. So first off, read the purpose and background section. And this is really, the whole purpose of this is really just to get familiar with making measurements, measuring things, and then working with those numbers. So we'll first collect the things we need. We'll need a calculator, 5 pennies, which I have somewhere around here. 1, 2, 3, 4, and 5. And a dollar bill. And I didn't have a $1 bill, so I had a $5 bill. But since I'm going to talk about how we measure that today, and I don't want to give you already the measurement for a dollar bill, I'm going to swap out my dollar bill, actual $5 bill, for a dollar bill meme. So there you go. I'm going to be measuring a dollar bill meme. So, all right, so here we go. We're ready to get started. We can dive right into the procedure and start making some measurements. So it says measure the distance across the longest edge of a $1 bill, first in inches and then in centimeters. Keep sig figs in mind. All right, so the first thing you do is going to be in inches, and whenever you start to measure things in inches, the very first thing you need to do is, get your curse words out, because measuring in inches is not fun. So I'll show you why. So we're going to line this up at the beginning. So inches starts here, the beginning of this measurement, and we'll go all the way down here. And so hopefully you can kind of see what we're looking at. And you see that it goes through here to this point right, oops, I moved it, right here really, like right there. All right, so when you look at an inch, it's not split up a normal way. 1, 2, 3. Yeah. So if you were to count these between 4 and 5, there's 1, 2, 3, 4, 5, 6, 7, 8. That's not the normal number system that we use. We normally like to use tenths, right? So that if it's that would be 4.1, 4.2, but it's not that way. We have to think of it this way. In the middle is half of an inch. I can write that a little bit bigger. 1/2. Half of an inch. Wow, that's still terrible handwriting. And then in the middle of that is 1/4 of an inch. And then on the other side, in the middle of that, halfway, would be 3/4 of an inch. And then in between those would be eighths. So that would be 1/8. And I can go the other way. This would be 1/8. The one in between 1/4 and 1/2 would be 3/8, because 1/4 of course is 2/8. So 3/8. And then 5/8. And then this last one would be 7/8, because it's 8 total segments. All right, so back to measuring our dollar bill meme. We were just before the 1/4 inch segment. So how exactly do you do that? It's somewhere partway in between the 1/8 and 1/4 inch segment. So it's really impossible to get an extremely precise read here, and that's why you sort of don't like what's going on, because it's not exactly halfway in between 1/8 and 1/4 inch. So 1/8, if you divided the fraction, so we'd be 4 and 1/8, and 4 and 1/4, and If you turn these into fractions, you could grab your calculator and divide 1 by 8, and you get 0.125, and then 1 divided by 4 shows you 0.25. There we go. So this is essentially the same thing as saying 4.125, and this is 4.25. And so here, it's almost to the 4.25 line, the 4 1/4 line, but a little bit before it. And you're just gonna have to estimate the best you can there. What is it most of the way toward this? Is it like 4.20 or 4.22 or 4.23? Maybe I'll say 4.21 inches. And this sort of demonstrates why the English system is such a crappy system to be using. So then we'll go ahead and make the same measurement in centimeters, and hopefully this will work out a lot better. Because centimeters are divided into tenths. So if you see where our dollar bill meme comes on the tenths, it's just, you probably can't see this really well, but this line here is the 10 line, of course, and this line here is the 11 line, of course. And you can see that it's past the 10.5. It's actually slightly past the 10.6, and you can just count that 10.1, 10.2, 10.3, 10.4, 10.5 is this big one, and then 10.6, and it comes just past the 10.6. So that means it's somewhere between 10.6 and 10.7, but it was closest to 10.6. If the 10.6 and 10.7 lines here, it was just barely past the 10.6. So I would say something like 10.61 or 10.62 centimeters for my measurement there. So that's how you make the measurements. Make sure, as always, that you're reading one decimal place beyond the markings shown. So we have a mark at 10.7 and 10.6. So you should be estimating one digit beyond that, and that last digit is your estimated place. That's how a normal, reasonable measurement system works. Okay, so then you can go on to do the math. So the math just goes on to tell you, you make the measurement in inches first and then in centimeters. Keep significant figures in mind. Record these values on your report sheet. So you'll go ahead and come over here and report them in inches and centimeters, and then it tells you to divide the number of centimeters by inches. So that'll give you the ratio of how many centimeters there are in 1 inch. And then it asks you to go on. So you'll do that 3 times. You'll repeat that measurement 3 times. And you might get very similar values. You'll just do the best you can. You might make slightly different estimates each time based on how you line that dollar bill up. And I expect that you make slightly different measurements each time, because you can't line it up in exactly the same place each time. You know, no one's perfectly exactly the same way. And maybe to get a better estimate, you might even flip it around and measure the other length of it on the other side. Okay, so either way, whatever you get, you'll go ahead and report them on that sheet. You'll divide them. Then it asks you to find the standard deviation. And it tells you right here, calculate the standard deviation, average, and percent error. Of course, you all know how to do averages. Standard deviation, you can go ahead and use, you don't need to do by hand. You can use a calculator or Excel to do that for you. And I have advice for you on each of these points. So how to do standard deviation, I recommend Google it. Whatever calculator you're using, for example, I have here the TI-34, go to Google and ask how to do a standard deviation on a TI-34. It's actually pretty easy, and I could show you the steps in about 30 seconds, but I won't, because everybody's calculator is a little bit different. So just go to Google. There will be someone on YouTube or just someone writing out instructions for how to do it. Spreadsheet programs are super easy. You just need to know the formula to enter, and it's very simple to do. So just go Google how to calculate standard deviation on whatever. Next, the average, I think you all know how to do. And last is percent error. The percent error formula is here. Percent error is calculated as your value minus the accepted value. So whatever you got as your value, which should be your average value, minus the accepted value, which in this case, you'll be using the accepted value of centimeters per inch, which is found on your yellow sheet. So look up how many centimeters there are in 1 inch. 1 inch has how many centimeters? And that's the accepted value divided by the accepted value. And since it's a percent, don't forget to multiply by 100. You don't need to write these down from the sheet because those are all, you'll be reminded of each of those things over here when you do your report sheet. It'll tell you how to do it. Okay, moving on. So that's how you get through those so far. Next, we move to the pennies exercise. So grab your 5 pennies. Make a stack out of them, like that. It's hard to see, but there are indeed 5 pennies stacked together there. I'll take them out of line so you can see it a little bit. The 5 pennies stacked together. And then you're going to use your ruler. And for this, make sure you definitely make the measurement in centimeters. I would recommend just folding it over or cutting it so that you can have a straight edge. And then go ahead and measure the same way. Measure the diameter across and measure the height of that column. And actually, I folded it slightly the wrong place. Make sure you don't fold at the line at the edge of the ruler, but at the 0 centimeter mark when you do that, to measure the height. All right, so that's how you'll measure the height, and then it's going to have you calculate the volume of the stack of pennies, which you use this formula for here. And again, you don't need to measure that, or you don't need to write it down from here because you'll be reminded of that on your report sheet when you need it. One little caveat here is make sure you do this in centimeters. Make sure you calculate that in centimeters. Don't use inches at this point. From that point, you'll need to calculate the density. Density is mass over volume. And of course, you don't have your lab kits yet, so you don't have a balance and can't weigh those pennies. So you'll use the volume that you calculated above as your volume, and the mass, you'll just have to come back over here and use the mass that was given in the lab sheet will be your mass. That's pretty much it. Then you'll go on to answer the extra questions in the lab, and it should be pretty straightforward. So hope it works out well. Happy studying.